Video from my computer science NEA, which is the Minesweeper game and solver. Now I'm going to go through the objectives which I set up at the beginning of the project and compare them with the final project. I separated the objectives into three categories, which are the user interface objectives, the game objectives, and the solver objectives. The first category is the user interface objectives. The Minesweeper consists of one Python file, which I'm going to run right now. Objective 1.1. After starting the program, the user should be able to choose one of the two modes. Here we can see initial screen, which consists of two buttons. We can choose either of them, which are the game and solver. Next, objective 1.2. Next, the user should be able to choose the difficulty. Here we can see the mode difficulty screen, which consists of three buttons: easy, intermediate, and expert. Objective 1.3. After every game, the status window should be shown. Here we can see the status window. It shows the status of the game, time to complete the game, mines left, and non-revealed cells left. Objective 1.4. After every game, the user should be able to return to the main screen or play the game with the same mode and difficulty again. Here we can see two buttons, which are Start Again and Main Menu. To start the same game again, we can choose this button, and we can play the game on the same board. To return to the main screen, we can choose this button. And notice that we can choose either of the buttons to play either of the games. And after it finishes, we will be able to see the status window. Here the status is restart as the solver didn't complete the board. We can see the time, mines left, and non-revealed cells left. And we can return to the main menu or start again. Next, let's go to the game objectives. Objective 2.1. The user should be able to flag a cell on a long click and reveal it on a short click. Right now, I'm going to long click on a cell. We can see that we put the gray circle in a cell, which denotes a flag. Right now, I'm going to short click on a cell. We can see that it got revealed. Objective 2.2. The user should be able to unflag a cell by long clicking on it again. Let's flag a cell. And now I'm going to long click on a flagged cell again. We can see that we have put the flag off, and now the cell is not revealed and not flagged. Objective 2.3. The user must be notified that they have lost the game when they open a mine. So we got notified and we can't play on the board. Right now I'm clicking and it doesn't do anything. We have the status window, and we have two options: to start again or to return to the main menu. Let's start the game again. Objective 2.4. The user should be able to see the locations of mines after they have lost the game. The location of mine which caused the loss must be marked. So right now we can see the location of mines denoted by X's, and we can see the location of mine that lost the game by L. And notice that if we flag some cells and then lose, we can still see these flags. Objective 2.5. The user must be notified that they have won when they have put the required number of flags and opened all the other cells. So as this board is quite big, let's return to the beginning mode and complete the board. Yes, so as we put the required number of flags, we see that we have won the game. And we see status win, the time we have completed the board, the mine and non-real cells left are both 0. So now let's go back to main menu and intermediate mode. Objective 2.6. The first click must always open a 0 cell. So as we have noticed, it always open a 0 cell. We can start again. And yes, we can notice that it always opens a 0 cell, and it also reveals all the other 0 cells. We choose some other objective. Objective 2.7, the algorithm must automatically reveal cells adjacent to the 0 cell, which is true, as we can see that, for example, this neighbor cell was also 0, and the algorithm automatically revealed all the neighbor cells, and we got the other 0, so it also revealed these cells. And here we got other 0, so the algorithm revealed all the other cells. And in the edge we only have non-zero neighbors, which are not revealed. I mean, their neighbors are not all revealed. Objective 2.8. The user should be able to reveal all the unopened cells in case the cell already has the necessary amount of adjacent cells. File flags by short-clicking on a cell. So let's start again. And so I've put a flag as this cell only has one neighbor mine, and it only has one neighbor unopened cell. And let's look at this cell. It already has one neighbor flag, so we should be able to reveal this cell by tapping on this cell. So let's short click, and this cell got revealed. Now I've put the other flag, and we can similarly see that this cell already has two neighbor flags, and we should be able to reveal 3 of these cells by short clicking on this cell. And the same for this cell. So this is the objective 2.8 done. Now let's look at the objective 2.9. At any point of the game, the user should be able to find out the probabilities of containing the mine of cells that are not revealed. So we can tap on this button, which is always here, and find out the probabilities of cells, which in this case denotes that this cell has 100% probability of containing a mine, and this cell has 0% of probability of containing a mine. So we can short click, and we can see that these probabilities disappear. And we can continue the game. So these are all game objectives. Now the solver part is a bit more tricky, as the solver, as the game, only solves the board and then shows the status. So it goes on with solving. And after a while, we can see the status window and the buttons. The objectives are related to the algorithm which I used in the solver. So I'm going to change the code a little bit so we can see what the algorithm actually does. So objective 3.1, primary check, only analyze the information about a particular cell. So on level 1, we only need to analyze the information about the cell, which means that we only analyze whether it already has the required amount of flags or it only has the required amount of non-revealed cells, which we cannot flag. And here I have the function which basically does it, and I'm going to output the cell, and I'm going to firstly just output it and then use the function sleep in the library time to see how it is doing after some, so we can see some time between these changes. So let's stop and start again. Yes, so we can see that a bunch of cells are revealed by level 1. And we can see that they are both flagged and revealed. Let's stop it and let's put time sleep for half a second. So we can see the locations of cells which are considered right now, and because the game goes in a while loop, we can see it outputs a couple of times. And it goes on with revealing and flagging cells. So this is the first level. I'm going to comment this again. Objective 3.2, analyzing two adjacent cells. So this is the level 2. And I'm going to open the part of analysis which relates to this level. As I explained, I combined the patterns in a common pattern which I deduced by doing some calculations, and I'm going to print the cells which are we considering, and I'm going to point out the patterns which the program uses. And notice that at this level we only consider information about two neighboring cells which are only neighbored by horizontal or vertical edge. And here I put half a minute sleep time. So it's better. Yes, so let's do solver. Yes, pattern recognizes cell 8-7 and 8-8. So this is, I think, those two, which is basically this pattern. As we can see, this is 1 and this is 2, so we will be able to flag this cell and reveal those cells. Let's check again if it's these cells. Yes, so that's what happened. We revealed these cells and flagged this cell. 8-8 and 8-9. So these are these two cells. This is the same pattern, so we are going to flag this cell and we are going to reveal this cell. Pattern 7. Yes, let's wait. Yes, that's what happened. And it goes on and on. We can do the other test. But basically, yes, this is the same neighboring information calculation, which denotes the same patterns. I mean the different patterns, but it all is combined in the same calculation. So let's go on a different level. And I need to comment all of this. Objective 3.3. Analyzing two cells distance one from each other. So this is a little bit trickier, as the next levels only go on if the two first levels didn't work. So that means that they go on in much less percentage of all distributions. But let's see if it's possible to get a distribution in which we will be able to see these combinations. So we can see that the pattern appears in cells 3 and 1, and now we can reveal these cells, which the solver did. Now we can see that the pattern appears in cells 14, 6, 13, 8, which are respectively this cell and this cell, and respectively this cell. We can see that the pattern appeared in the cells 14,8 and 15,7, which are this and this cell. And we can reveal this cell. Now let's wait for solver to do it. Yes, what the solver did. And the board is completed. So that's the objective 3.3. Now let's go to the objective 3.4. Probability calculator. Calculate the probability that a cell contains a mine. I will cut the video as the same as in the previous objective. The board doesn't do this level as frequently as the first two. And we can comment this level. And go to the solver and uncomment this. I set the time to sleep to be 1 minute here. So we can see that we can reveal a cell 17,4, which is this cell. And it couldn't be revealed on levels 1, 2, and 2.5. We can also reveal a cell of 18,0, which is this cell. We can also flag a cell 18,1, which is this cell, and we can see that it makes sense because, for example, this and this ones will have one flagged cells, and therefore this cell should be revealed. And we can also reveal a cell 18,3, which also makes sense based on this one and this two, as this two already has one flag, and this one will have this flag. And as we can remember, this cell and this cell should be revealed. And so we can flag the cell 18,4, which is this cell, which also makes sense based on this 3. And now we should see the notification that we can reveal this cell. And we can see that it all sums up to a good board, as we can see that all these numbers, all these cells has the required number of mines. Yes, and the solver did basically the same that we saw in console. And we can also see that the probabilities appeared. So this is the end of testing, and more examples of probability testing will be provided later in testing section, as some of these distributions are quite big and there are a huge number of possibilities. So I will describe them later.